Hello again, it's Mrs. Value, and thanks for tuning in. Today, for math in third grade, we will be doing some fluency practice, working with multiplying and dividing within 100. So if you've had a chance to look at your extended learning packet, you'll notice that the math looks a little bit different than it did last week. For this week, we have 5 problems on one page, and each one of these problems, again, deal with practicing fluency with multiplying and dividing within 100. So today, we're going to do a little warm-up. Then we're going to review some key skills to be able to solve these multiplication and division problems. We're going to complete a few questions together. So if you are on the computer, you may want to, after I read a problem, you may want to pause, try and solve it yourself, unpause, and then I will solve it in different ways. I will go over the answers as well. If you are on the television watching, you may want to just walk through it with us and then go back after the video and try and solve it, maybe in a different way than I solved it. Challenge yourself a little bit. And then, of course, we're going to close with a challenge question that I think is pretty fun. So let's go ahead and get started with a warm-up. I want you to think about 6 times 4. Can you think of 2 factors when multiplied that equal the same as 6 times 4? So again, this is a part where you can pause and start thinking about it on your own. Otherwise, we're going to kind of move forward, okay? So the first thing I need to do in order to solve this is I need to understand what factors are, okay? So factors are 2 numbers that when multiplied give me a product. And I also need to determine what the product is of 6 times 4, okay? So when I think about 6 times 4, I can also think about it in terms of 4 times 6. And I know that 6 times 4 and 4 times 6 gives me 24. Okay, so now that I know that gives me 24, I can think about 3 times 8. I can even think about 1 times 24 or 2 times 12. So, can you think about 3 products when multiplied, or 3 factors when multiplied gives you the product of 24 or 6 times 4? Again, this is a chance where you can pause and try and challenge yourself. Otherwise, we're going to keep moving on. Okay, so when I look at 6 times 4 and I'm thinking about breaking it up into 3 factors, first thing I'm going to do is I'm going to think about that 6 and I'm going to break apart or split up that 6, okay? So I know that I can take 2 times 3 and I can get 6, okay? Because I know that 6 times 4 is going to give me 24. So 3 factors that I can use to get 24 are 2 times 3 times 4. I can also leave that 6 the same and just break apart that 4. So I can say 6 times 2 also gives me 24. So these are just some warm-up questions that kind of get us started before we get started with our questions from our extended learning packet. But before we get to the extended learning packet, let's go over some key skills to remember because we will reference these throughout the lesson. So some key terms to remember, we've already talked a little bit about factors and products. Factors are the 2 numbers when multiplied, gives us the answer, which is the product. And also in thinking about division, okay? So the dividend is the number that's being split apart, okay? So in this case, 40 is being split apart. The divisor are the number of groups. So I'm splitting 40 into 8 groups. So the quotient, which is the answer to our division problem, is how many are in those groups. Okay, so those are just some terms to think about as we move through our problems. So in thinking about fact families are an important way to think about multiplication and division, okay? So as you can see here, I have 20, I have 5, and I have 4, okay? So I know that these numbers can work together to help me with multiplication and division. If 5 and 4 are my product, 5 and 4 are my factors, then I know that 20 must be my product. And I know based on the commutative property of multiplication that I can switch these factors and put them in different orders and still get the same product, okay? So in thinking about our division here, if 20 is being broken apart into 4 groups, there's going to be 5 in each group. So 5 would be my quotient. I can also take 20 and break it up into groups of 5, and 4 is going to be in each group, as you can kind of see here. We'll go over one more example of a fact family. So we have 15, 3, and 5, and you can see how these numbers work together to multiply and divide. When we think about our fact families, think about how multiplication and division are related and how they can help each other. Multiplication chart is another easy one that we can use if we just kind of want to check our answer, make sure that we have that answer. So in order to use a multiplication chart, take the first factor in your problem and find it here on the side. So in this case, if I'm trying to determine what 4 times 5 is, I'm going to find that 4 here on the side, and I'm going to move over 5 columns. Okay, making sure that 5's up there, and then I come to the number 20 because 4 times 5 equals 20. Another great handy way to multiply is use the distributive property of multiplication. Okay, we can split these numbers apart to help us multiply. So let's look at our example here, 9 times 7. If I'm struggling with 9 times 7, I can think about factors that I know really well that can help me. So in order to solve this, I'm going to take this 7 and I'm going to break it apart into a 5 and a 2. I know my 5s really well and I know my 2s really well. So I'm then going to say 9 times 5 gives me 45 because I know my 5s really well. And then I'm going to say 9 times 2 gives me 18. And then I'm going to add those together, which would give me 63. I could go back into my multiplication chart just to check my answer, make sure that I got it correctly. Or I can use these numbers to be split apart. When we split apart numbers, think about how we can use numbers that we know well. Make those friendly numbers if possible, okay? All right, we can also skip count, okay? So when I think about my 5s or my 2s or my 10s, skip counting is easy for me. May not be so easy with some other numbers, just depending on your strengths. But in this case right here, jumping by 5s to get to 40 would be easy for me because I can do that. And you can see here that 5 times 8 gives us 40 because there's 8 jumps of 5. Okay, so now we're going to move on over to question 1. So again, after I read the question, if you're on the computer, pause. And try and solve it yourself and then come back to us. But if you're on the TV, try and think about different ways you might have solved this problem other than a different way than I solved it. So let's go ahead and look at question 1. Mr. Allen writes an expression 6 times 3 on the whiteboard. Which of the following expressions have the same product as Mr. Allen's expression? Circle all that apply. So when I look at this, there's a couple key things I need to take a note of before I start to solve it. First thing, it says circle all that apply. So I know that there's probably going to be more than one answer. I also need to think about 6 times 3. Okay, so I know that 6 times 3 has a product. When I look down here, I don't see the same 6 times 3, and I certainly don't see products down here. I see all factors, so that's going to be something that we need to take into account. So I know that 6 times 3 is 18. You could use a multiplication chart. You could use other ways to figure that out, but I know it has 18. So I know each one of these, if they're going to apply, if they're going to be part of my correct answer, they need to have the product of 18. So as I look down through here, some of these have 3 factors, and I just don't know right off the top of my head if they're 18. But as I look at C right here, I see that C is 3 times 6, and I know the property of the commutative property of multiplication says that I can multiply them in any order and still get the same product, which is true. So 3 times 6 does equal 18. They're found differently on the multiplication chart, but they both equal 18. So I know that C would definitely work. Okay, so let's take a look at, go back to A. It has 3 factors. I have to work it out to determine if it has the same product. So when I look at A, I say 3 times 2, which gives me 6, and then 6 times 3 gives me 18. So A would definitely work, okay? When I look at B, I see 6 times 4. Well, I know that's an extra group, so I know it's going to have a larger product than 18. And in fact, it does. Okay, I can see 6, and I can move over 4 columns, okay, making sure the 4 is still above there, and I see 24. So I know that B would not work for this. We've already determined that C works, so let's go on to D. I see 3 times parentheses 2 times 4 in parentheses. So I'm going to solve what's in the parentheses first, which is 8. 3 times 8 gives us 24. So I know that that product is greater than 18, so it would not apply. So looking at E here, I've got 2 times 3 times 3. So I know that 2 times 3 gives me 6, so 6 times 3 gives me 18. So thinking about question 1, A, C, and E would all apply. Okay, so moving on to question 2. So you know that 9 times 6 equals 54. Use the numbers 9, 6, and 54 to fill in the blanks below. So again, we're working here with fact families, right? So when I think about my fact families, all right, I know that I have my 2 products, and my 2 products are going to give me, my 2 factors here are going to give me my product, okay? And then I know I can take that product and I can split it up into these groups and get those answers as well. So for this problem right here, I would have 9 times 6 equals 54, and 6 times 9 equals 54. 54 divided by 6 equals 9, and 54 divided by 9 equals 6. Okay, so question 3. Brian says that he can make 4 different equations using the numbers 7, 8, and 56. Write the 4 equations Brian can make. So I'm going to just check to see if Brian's work is correct. So one thing that you can do if you're really comfortable with your 7s, you could skip count by your 7s. You could skip count by your 8s. You could create a number line to check. And you can use the other methods that we talked about as well, just to check to make sure his answers are correct. But in looking at this number line that I have here and the jumps by 7, okay, I have 8 jumps of 7, which does give me 56. So I can say that 7 times 8 equals 56, 8 times 7 equals 56, 56 divided by 7 equals 8, and 56 divided by 8 equals 7. So are there any other ways that we could solve this? Think about it. So moving on to question 4, select all equations that are true. So I need to go through here and I need to solve each one of them to determine if they are true. So let's start with A. So 5 times 8 equals 40. So what I could do, because I know my 5s really well, is I could skip count by my 5s, okay? And if I skip count 8 times, I get 40, okay? I could also say 40 divided by 5 equals 8, okay, to help me determine that A is true. Let's go ahead and look at B. We have 8 times 6 equals 48. One way we could determine that is to skip count by our 6s if we feel really comfortable with that to help us. And so based on this number line and this skip counting of 6, I get to 48 with 8 jumps, meaning that 8 times 6 does equal 48. Let's go ahead and take a look at C. So 7 times 4 equals 35. So I'm not really that good with my 7. So I'm going to use a distributive property or split my number 7 apart to create 2 different multiplication equations that I feel really comfortable with. So I'm going to take that 7, I'm going to break it apart into a 5 and a 2 because I know my 5s really well and I know my 2s really well. Okay, so once I do that, I'm going to say 5 times 4 gives me 20 and 7 times 2 gives me 8. And now I've created very friendly numbers and I can add those together and I get 28. So when I look back at C, I see that C says 35. Well, I know that that is incorrect. So C would not work for this one. So in looking at D, D says 9 times 9 equals 82. I'm again going to split that 9 apart and to kind of see. I don't know my 9s when they get really high up there. But I bet I could split apart one 9, and then I could think about my 9s for my 4s and 9s for my 5s, and I bet I could get this. So I broke apart a 9 to 4 times 9, which gives me 36. It's a small number I can add up. And then I'm going to say 5 times 9, which gives me 45. Okay, and again, I know my 5s really well. So when I add those together, I get 81. And when I look back at D, it says 9 times 9 equals 82. Well, I know that's not correct because the correct answer should be 81. Okay, so moving right along to question 5. What pattern do you notice in the products when multiplying the same factors by 10 and then by 5? So let's take a look at the very first number string right here when we're multiplying by 10. So I notice that the first factor is going up by 1 each time, and the second factor is staying the same. So I think that my product is going to be going up by 10 each time because it's an additional group of 10. So as you can see, 4 times 10 equals 40, 5 times 10 equals 50, and 6 times 10 equals 60. So it's going up by 10 each time because it's another group of 10 that we're adding on. If the pattern continued, it would be 7 times 10, which would give me 70, just another 10. So when I look at the next number string here, again, the first factor in each problem is going up by 1, and the second factor is staying the same. Okay, so 4 times 5 equals 20, 5 times 5 equals 25, 6 times 5 equals 30. So it is going up by 5 each time, okay? Because here, my second factor is 5, so it's going up by 5 each time. Can you find another pattern? Okay, so before we close, I'm going to leave you with a challenge activity. And I thought that this was a really fun challenge activity. So what it wants you to do here is it wants you to find the value of each icon in the multiplication table below. For instance, here are your factors. Here are your factors on the side and on top. And inside here are the products. That means they're going to be the answer to the multiplication problem. So, for example, this says that a regular sandwich times 7 gives us cola, okay? But we've got to determine the value of that cola and that regular sandwich, as well as all the other icons in here. So, if you're on the computer, go ahead and pause and see if you can figure it out. Otherwise, we're going to go ahead and solve this. So, when I first look at this puzzle, I notice the 7 here because it's a value I know, and it also has a 7 here inside the table, which means I'm multiplying something by 7 to get 7. The only thing I can multiply by 7 to get 7 is 1. That's the identity property of multiplication. So I know that this sub-sandwich has to be 1. So let's check and see, make sure that it's right. If I have a sub-sandwich here, and a sub-sandwich up here, this must be 1 as well because 1 times 1 equals 1. Okay, so let's move over here to this 5. 1 times what equals 5? Again, this tomato has to be a 5. Okay, so let's go over here to where we see a 3. 1 times what equals 3? So now I know my regular sandwich is a 3. So I'm going to go up here to this other regular sandwich, and I know that 3 times 7 gives me 21. So then 3 times 5 must give me 15, which gives me 1 as the sub sandwich, 5 as the tomato, 3 as the regular sandwich, 21 as my cola, and of course 15 as my toaster. So I hope you have enjoyed our video today, and I hope it has helped with some of those fluency problems. And I hope you also enjoyed the challenge activity. Thanks for tuning in, and don't forget to look at our other resources found on our Knox County website for math. Thank you guys so much.